We're going to create a trigger for auditing a table. Now, a database trigger is precompiled code. It's a database object. And the thing to know about a trigger is it fires every time that the table is modified based on the modifications and the type of triggers that you've written. Remember that because the trigger fires every time the table is touched with intent to modify, don't do error checking inside a trigger. High resource requirements and the need for speed. You can use triggers for archiving data as long as the table, the archive table, is in the same database as the table that is being archived. Not every production table needs to be archived. This is going to be strictly a business decision based on compliance and conformance rules. Avoid cross-database triggers because a trigger fires within the scope of a transaction, and that's going to cause those resources to be locked up for the tables, the two tables in the two databases that are involved in the trigger firing until the transaction is completed. Could be a huge performance hit. And every production database that's being archived needs to have a counterpart table in the same database with the following differences. For each archive table, you're going to remove any table or column constraints, no error checking. You're going to drop any production indexes. You're going to add an archive ID, which will be an integer, an identity, and non-clustered. You're going to add an archive DDL, a CAR3, to record the modification action, and an archive date, which defaults to get date, a clustered index on the archive date. Any other indexes is needed, but please very judiciously. Archiving captures what actually happened in the production database. It does not try to fix or constrain the data. So we're going to use the CIAC database, and then we are going to create the trigger. And because we've got an indexed view on this table, ANSI nulls and quoted identifier have to be set on. Create the trigger, give it a name on the specific table, and after insert trigger, then puts data into the order header archive that reflects what was inserted. A trigger to capture deletes. After the delete, puts data into the order header archive table that reflects what was deleted. A trigger to capture updates puts data into the order header archive table that captures both what was deleted and what was subsequently inserted. An update operation is first a delete, and then it is next an insert. So you've got two parts to any update capture. Trigger management, very quickly, you can disable a trigger simply by executing the alter table trigger name, disabled trigger, or alter table table name, disabled trigger trigger name code, and re-enable the trigger simply by saying alter table table name, enable trigger trigger name. Determine which tables have triggers on them, execute this little piece of code, and there you go. You can see the triggers on your tables. To test the trigger, I want to do a normal insert operation, and I'm going to execute the stored procedure to insert data into the order header table. It's identity number 41, and I'm going to check the archive table. I have order ID 41, and there it is. It's an add, and this is the information that I gave it. A normal delete operation. I want to make sure I've got the right record to delete before I execute the stored procedure to delete data, and I delete it. And now I'm going to check the archive table, and it is a delete on order ID 41. A normal update operation, I want to make sure I've got the right record. It's number 40. I'm going to execute the stored procedure to update data, the delivery date, from the 10th to the 12th. And then I'm going to check the archive table. And as a matter of fact, skim down here, order ID 40 went from the update delete, deleted the 10th to the 12th. And that's it.